I suppose y'all are wondering why I called you here today. Called him here today again. Oh yeah, we're going to be looking at the age-old question of the PMS, wait a minute, the PMF versus the PDF. What's the big deal? The short answer is they're basically the same thing. The only difference is that we use PMF when we're talking about discrete distribution and PDF when we talk about continuous. That's it. Now pay attention because we're going to be moving fast here. And that's the difference between a PMF and a PDF. Okay, actually one more note. Some textbooks will do this and some professors will, but others won't. So it's kind of up in the air. I personally like to follow this notation, but for a discrete, but for a continuous, and this is just reserving F for a true function rather than P for a discrete probability. I don't think any professor would take points off if you used one or the other, but it's just for clarity's sake. And that's it. That's the difference between a PDF and a PMF. Okay, there actually is one more thing yet, and this is again kind of technical. The probability of the random variable x being a realization x is equal to some number. If you roll a die, you have a 1/6 chance of rolling a 1. But for a continuous distribution, the probability of the random variable being a realization at that specific number is actually 0. Something to do with limits as the number of decimal places go to infinity or something like that, right? We always have to take a range, and that's why we integrate so we can get an area. But if that integration, if that delta x on the bottom goes to 0, you technically have a 0 probability. And you can just keep adding on decimal places, so the probability of this exact number happening technically shrinks to 0. And that's why we need to integrate over a range. Okay, that's it. Now you know the difference between a PMF and a PDF. Go forth. Thanks for watching, and I hope you gained a little bit more knowledge about a topic that doesn't really matter because they're basically the same thing. It's just notation.